How many coulombs are required for the complete reduction of 200 ml of 0.2 molar KMnO4 solution in acid medium? First of all, by using molarity and volume, we'll calculate the number of moles of KMnO4. Molarity is equal to number of moles into 1000 by V in ml, molarity formula. Molarity is 0.2 is equal to N into 1000 by volume is 200. So 5 times it will get cancelled. Number of moles of KMnO4 is equal to 0.2 by 5, that is 0.04 moles of KMnO4. Here they mentioned that the KMnO4 solution is an acidic medium. In acidic medium, MnO4 minus changes to Mn plus 2. In acidic medium, MnO4 minus changes to Mn plus 2. In MnO4 minus, Mn oxidation state is plus 7. Plus 7 is changing to plus 2. That means it is undergoing a reduction, and the difference in the oxidation number is 5. Difference in the oxidation number is 5. That means to balance the equation, we should add 5 electrons on the reactant side. Then both the sides it will become plus 2. So now based on this, we can understand that for 1 mole of KMnO4 to undergo reduction, it requires 5 into 96,500 coulombs of charge. 5 Faradays is required. 1 Faraday is 96,500. So I am considering that as 5 into 96,500 coulombs. For 1 mole of the KMnO4 to undergo reduction, it requires 5 into 96,500 coulombs of the charge. Then for 0.04 moles of KMnO4, how much charge is required? That is X is equal to 0.04 into 5 into 96,500. We'll get the value 19300 coulombs. Okay. So how many coulombs are required for complete reduction of the 200 ml of 0.2 molar KMnO4 solution in acidic medium is 19300 coulombs.